Hi, I'm Hong, a PhD student at School of Architecture of Tsinghua University. I'm honored to be here on behalf of our team. The title I'll talk about is a dynamic analysis of daylight availability in dense urban residential areas, a cross-region study in China. In China, there are two building regulations relating to daylighting planning. They specify two evaluation indexes for daylighting design, daylight factors and minimum requirement of sunlight hours in typical days. However, in some emerging dense urban residential areas in China, daylight availability is still in poor condition. Current daylight planning strategies may be unpractical and without reflectance of daylight conditions. This study presents a climate-based simulation analysis for daylight availability in dense urban residential areas in 5 Chinese locations. Each of those locations represents one of the 5 daylight climate zones in China. This figure presents Chinese daylight climate zones 1 to 5. Zone 1 gets the most annual average total illuminance, while Zone 5 gets the least. The 5 representative locations are Lhasa, Yinchuan, Beijing, Guangzhou, and Chengdu. 3 typical urban layouts in residential areas were studied. The building dimensions and distances were defined to achieve the highest building density, according to both national and local planning regulations. External vertical illuminance at the central external window of building was calculated by Dasim. Here is a linear relationship between external vertical illuminance and indoor average daylight illuminance at the working plan. The k-value was achieved based on the regression analysis using local weather data. In this study, k-values were used as 8 for Lhasa, Yinchuan, and Beijing, 9 for Guangzhou, and 9.5 for Chengdu. The external vertical illuminance ranges as proper, excessive, and poor external vertical illuminance. The annual frequency of the external vertical illuminance from 6 o'clock to 18 o'clock can be used to justify the potential of daylighting in buildings. A higher frequency of proper vertical illuminance indicates a proper indoor illuminance. If the frequency of excessive vertical illuminance has a higher value, the facade surfaces will receive excessive solar gain and daylight illuminance. These figures present frequencies of different ranges of vertical illuminance at south facades at 3 typical positions: ground, middle, and top floor. The red columns present the excessive vertical illuminance, and other colors present the proper vertical illuminance. In general, Guangzhou and Chengdu have higher proper illuminance frequencies and relatively lower excessive illuminance frequencies, while Lhasa and Yinchuan have the higher excessive illuminance frequencies. Beijing has a medium levels. The differences between the 3 facade positions are larger in Lhasa and Yinchuan, but less clear in Guangzhou and Chengdu. For each facade position, it has been found that frequencies of the same range are similar between layout 1 and 2. For layout 3, rectangular buildings would receive slightly higher frequencies of a proper illuminance than square buildings. Based on a climate-based simulation analysis, some conclusions could be found. First, locations and climates play the most important role to achieve a proper daylighting utilization. In this study, Guangzhou and Chengdu have the higher potential to achieve useful daylighting, while Lhasa and Yinchuan have the higher risk to get problems of overheating and visual discomfort. Beijing has a medium potential. This could indicate that the 3 layouts are suitable for Guangzhou and Chengdu under current regulations, but may not for other locations. Without further modification of current regulations, it could be possible to give rise to environmental problems relating to land waste in some cities. Second, facade positions can take significant effects. Most planning regulations in China only focus on the ground floor, without considering local climates and higher floor positions. Locations with high annual average illuminance would have higher risk to get excessive solar gain and daylight illuminance. Third, with the highest building density allowed by planning regulations, urban layouts might have limited influence on the overall daylighting availability across the south facade in buildings. This study was implemented in 3 specific layouts. It would be interesting to check more parameters relating to the urban forms. Except for the south facade, other facades of buildings in the 3 layouts should be also studied. In addition, other typical orientations might deliver various impacts on the daylight utilization in these layouts. Thanks a lot for your attention. If you have any question, please send to our email. Looking forward to your voice.